Well, good morning and welcome to Advanced Math class. And I thought I would do this one with you because both of these are a little bit tricky, but only a little bit. So let me start with advanced trig equations, and then we'll do clock problems. Okay, these equations, you need to know these, okay? You need to know these. These are very, very significant. We're going to use them now. We're going to use them next year as well. These are important. I've said this on Discord. I'm saying it again, okay? You need to know these. All right, so they're giving us a problem like this. 3 tangent squared x equals 7 secant x minus 5. The book, if you're following along in your book, which is not a bad idea, they have thetas instead of x's, but x's are easier for me to type than thetas. So we got a problem here. We got tangents and secants. What are we going to do? Well, what we're going to do is to go back to one of those 3 equations I just showed you and replace the tangent squared with the secant squared minus 1. You're going to look in these problems, and when you have 2 different trig functions, and one of them is squared, that means you can probably switch it to the other one. So we know there's a relationship between tangent squared and secant squared, so we can get rid of the tangent squared and replace it with the secant squared, and now the whole equation is in secants. That's the new stuff. The old stuff, distribute, you guys know how to distribute, bring everything to the same side by doing the same thing to both sides of the equation. Now they factored, you're probably going to use quadratic equation. Either way, you get the secant of x equals 1/3 or 2, which if you do the trig gets you an x of either 60 or 300 degrees. I went through the latter part of that problem really fast because it's stuff that you've already done. The key step is that first one, getting it all into secants, and then getting everything on the same side of the equation so you can factor or use quadratic formula and get the angles. Okay? If you have problems with the latter part, let me know, but that's all that you've been doing the latter part. What you haven't been doing is this first part. Okay, here we have a sine squared and a cosine. Again, 2 different trig functions, one of them squared, so we can replace the squared, the sine squared in this case, with 1 minus cosine squared. Those 3 identities on the first slide are what you're going to use to change the squareds to the other trig function. So 1 minus cosine squared. And then again, distribute, bring everything to the same side. I did that in one step. Rearrange it, multiplied by a -1. Factor, or as I said, you guys will probably use quadratic formula because you guys aren't real good at factoring like this. Don't like the fact they do this. They don't teach us to factor like that. And then they use it a lot in these problems. And then that brings us down to what the cosine is, which brings us down to what x is, okay? And again, I went the latter part quickly because that part you guys have been doing. The only thing you need to remember is that first step, changing the squared of one trig function into the squared of the other trig function so the whole equation's in the same trig function, okay? It really isn't that hard, but I feel like you guys are struggling with some of these, using those 3 identities. You need to know those 3 identities and be able to use them. Okay, clock problems are like dirt problems with clocks or with time. They're a little bit weird, but they really aren't hard. In fact, they're actually really easy in some ways. Okay, so when you're doing distance, the distance is how many spaces around the clock the hands are moving. Okay, so it's like you have a big hand and a little hand. This is how they do the problem: big hand and little hand. I tend to want to do long and short, but they would do big and little. Anyway, so that's what we do it. The distance that their hand is moving is how many spaces around the clock. There's a total of, if you remember, 60 spaces the whole way around a clock because it's 1 hour. And so you're wanting to keep track of how many spaces the hand is moving. That's the distance. The rates, well, the big hand moves at 1 space per minute. Okay, 1 space per minute. So as the big hand is going around, it goes around 60 minutes, it goes around 60 spaces. The little hand goes 5 spaces in 60 minutes. If you think about the little hand, it goes from the 12 to the 1, or the 1 to the 2, or the 2 to the 3, which is 5 spaces on the clock. And it does that in 60 minutes, or it goes 1 space per 12 minutes, or 1/12 space per minute. Now, this is one of the reasons why these are not hard. These rates don't change. The rate of the big hand and the rate of the little hand are always the same, and they're always the same because that's how fast hands move around clocks. And the times are always equal because the time of the clock, the hands go together. You can't have one of them going for 10 minutes, the other one only going for 5. It doesn't work that way in a clock. So the times are always equal, Write that down. Okay, write this down for yourself. Take the time. I'll stop talking here in a minute and just leave it on the screen for you for a second. Write it down so you have these. Now, you can't have them on a test, but for now, as you're practicing, which is really the most important thing at this point is practicing, you need these written down so you can access them. So I'm going to stop talking and let you write them down. Okay, and while we're at it, text me, it's time, and then finish the video. Okay, how do we do these problems? First of all, you read the problem, then you translate, then you solve. Okay, so read the problem, translate the problem, and solve it. So you can read question 85.4. Let me pull my book open so I can read it with you. 85.4. The hands of a clock point in the same direction. In how many minutes will they point in opposite directions? Okay, so now you have to visualize the clock. The hands are on top of each other. At some point in the future, the big hand is going to keep on moving, and the little hand is going to wait for it. Okay? No, it's not, actually. The little hand is also going to be moving. And the question is, at what point will the big hand be directly across from the little hand? And the answer is it's got to be 30 minutes ahead. It's got to be 30 spaces between them because that'll be opposite of each other, right? On a clock, if the hands are opposite each other, then they are 30 spaces apart. So the little hand is going to move S spaces. However far it goes, it's going to go that far. The big hand is going to go 30 extra, okay? The little hand will be moving, but the big hand will be moving faster. And it's going to be moving 30 more spaces. And then this is our basic equation, RLTL and RBTB, because DL equals RL dirt, okay? Rate of the big hand is 1, and the rate of the little hand is 1/12, and the times are equal. Those last three equations are always the same, okay? First two equations are important. The last three equations are important, but they're the same in every problem. So we're kind of rewriting here a little bit. S equals RLTL. And then I subtracted 30 from both sides so that S equals RBTB minus 30. Well, since the two S's are the same, we can substitute effectively, and RLTL equals RBTB minus 30. Well, RL is 1/12. The times are the same, so I'm just going to replace it with T because they're the same time. RB is 1, T minus 30. So negative 11/12 T equals negative 30. So T equals 32 and 8/11 minutes. There you go. It's really straightforward once you get the first step, and that is important. I kind of wrote this. The most challenging problem is determining the two distances. The two rates and the time are already given to you in every situation. I mean, they're the same. So let's look at 85.5. It is 3 o'clock. In how many minutes will the two hands of the clock point in the same direction? Okay, if it's 3 o'clock, that means the hands are 15 spaces apart, right? And the little hand is at the 3, the big hand is at the 12. So the big hand has to catch up 12 spaces to catch up to the little hand. So the little hand will go S, the big hand has to go 15 more. It has to go 15 spaces farther in order to catch up. And then you do the rest of the problem. Okay? So if you didn't text me earlier, text me what I told you to. And good luck on these problems, and let me know if you do have an issue.